Hi guys, so you should be watching this video after you've completed the Khan Academy practice introduction to residuals. So you have a little background of what residuals actually are. I give you a little diagram at the top right-hand corner here just to show you guys that the residual is just the difference from the actual data point compared to the line of best fit, right? So it's kind of like our error. What's our difference between those two values? So a couple of fill in the blanks here, okay? So interpreting residual plots, it says the blank provides an idea of the blank when using the least squares line to make a prediction. Okay, so least squares line we're going to be referring to as our line of best fit. So the sum of the residuals, meaning when you add up all your residuals, okay, provides an idea of the degree of accuracy, meaning how accurate is our information. Degree of accuracy when using the least squares line to make predictions. Now it says the following guidelines apply if and only if you have established this is a causal correlation, meaning there's some kind of relationship going on, okay? So the closer the sum is to 0, the more reliable the prediction may be, right? So based on how close those data points are to the line, that means it's going to be a pretty reliable line there, right? But the greater the sum of the residuals, meaning if they're further away from the line, that means it's going to be less reliable. Less reliable that the predictions may be, okay? So what you see over here on the left-hand side, graph 1, original scatter plot, it's just our X values are the inputs from our data, and then the Y values are our outputs. So we know these are just kind of general coordinate points that are plotted, comparing shoe length and height, okay? And it looks like generally there's about like a positive linear correlation going on here. So if I were to just sketch out a line of best fit, looks like maybe something like that, okay? Now what you see over on the right-hand side, notice how it says residual here? This is our residual plot. For us, that's just gonna be plotting how far away are these dots from my line of best fit, right? So it's kind of if you were to like take that line and just kind of alter it and make it go horizontal, this is just showing you how far away distance-wise my data points are from my line of best fit, okay? So kind of just recapping up here, this is graph 2, the residual plot. It's the exact same data. This is just showing us how far away our data points are from our line. The X values are the inputs, once again. The Y values, but now are the residuals. So how far away were those data points from my line of best fit, okay? So the characteristics of a residual plot that implies there is a linear relationship are, okay, that there are no odd patterns, or curved trends. Curved, running out of space here, curved trends in the plot. It actually looks a bit scattered. The irony is pretty ironic. The irony is that even though a scattered appearance implied a no correlation in a scatter plot, a scattered appearance in a residual plot means that there is a linear relationship. Okay, so that's why students sometimes get confused. So technically this residual plot that you guys see, that is a great visual to show that, hey, my data actually forms a pretty decent linear relationship, even though it's scattered, because remember, that's just showing us how far away those points are from my line, okay? So technically, we look at those data points, the sum of the residual, meaning how far away they are from my line of best fit, is 0, and the points are equally represented above and below the x-axis. So if you look at your residual plot here, it looks like we got a couple, 1, 2, 3, 4, 5, 6 below, and we got 1, 2, 3, 4, 5, 6 above. So it's kind of like evenly dispersed above and below that line there, okay? So what you want to be thinking in your head right now, guys, is, okay, when I see a residual plot and it looks scattered like that, and I have an equal amount of points above and below, that's actually a great representation of a linear relationship, okay? And you're like, well, miss, it doesn't make any sense, because usually when we look at a scatter plot, if I see my dots looking like that, it means there's no correlation. But remember, this isn't a scatter plot, this is a residual plot. So anytime you have a residual plot that has scattered points like that, that means it's a great linear fit, okay? If you flip it over, I just give you guys some diagrams to kind of wrap up that idea here. So the top 3, okay? So it gives you, looks like a little bit of a scatter plot that looks like it's curved a little bit, okay? Curve kind of going up. Then my next one is kind of a little bit of a curve also. And then my last one looks like it's a perfect like line almost, if you were to put a line there. And then the following residual plots as well. So notice for the first two that are kind of curved, right? There's a general kind of pattern. It looks like there's about a curve going around this way, a curve going around that way. So those top two would not be a strong linear relationship, right? Because you're looking at your residual plot and it's not scattered, right? You see a pattern in your residual plot, meaning that the actual scatter plot is not a good linear fit or not a strong linear fit. Your last diagram of the scatter plot, right, if you were to put in a line of best fit there, it looks like that's a pretty strong linear correlation, positive linear correlation, right? You look at the corresponding residual, a bunch of scattered dots, that means bingo, that's a good representation of our linear data here, okay? There's a nice bigger picture right down below here that shows you, again, the scatter plot versus the residual plot. And once again, this scatter plot, that looks like a pretty strong positive correlation there, right? All the points are kind of close together, going in that positive trend. And then again, the corresponding residual plot, a bunch of scattered points. And that means, again, this residual plot with all those scattered points is telling us that we have a strong linear relationship, okay? Last but not least, there's technically a little multiple choice question here for you guys. So it says, which residual plot below would show that the data has a strong linear relationship, okay? So again, when you're thinking residual plot, you want to look for absolutely scattered points, no pattern. So it looks like you have a pattern for C, so it's not going to be C. We have a pattern for B, right? They're all increasing. Residual plots, you want zero pattern. You want them all to be scattered. So A will be the correct option choice there.